place more or less like our own, a world in its own right. But a detailed knowledge of what Mars is like had to await the mission of Mariner 9, an unmanned spacecraft which went into orbit around the planet Mars in late 1971 and worked for almost a year.
A geologist looks at a planet to first understand the processes that are going on there, the things that are affecting the development of its surface at the present time. But even more important, we try to look back in the past to place the events that have taken place over a long period of time, to understand what happened early in its development, in the middle part of its development, the things that are happening now, and to predict what might happen in the future.
For a biologist, one of the great scientific opportunities of our time is the search for life on Mars. That question is so important, it will change our whole concept of life. It will change our whole concept of how life originated. The question is not only whether there is life on Mars, but whether that life has a separate origin from our own life, life as we know it.
When Mariner 9 was placed into an orbit around Mars, it saw a planet 1/2 the size of Earth, blanketed by a gigantic dust storm. For almost 2 months, scientists could see only blurred pictures of the top of the storm, or the ice and snow of the South Pole shining dimly through the dust, and several dark spots, apparently mountain peaks protruding up through the storm. And then the great clouds of dust receded, and the long weeks of frustration ended with one magnificent and exciting word: volcanoes. The photographs bear little witness to the violence in which these volcanic mountains were born. On Earth, the eruption of volcanoes created the atmosphere and produced the water that fills our oceans and rivers. On Mars, the same magic of physics and chemistry created a thin alien atmosphere and provided a source of water on a planet known to be drier than the Sahara. The exploration of Mars by early mariners photographed about 10% of the surface in brief encounters as they flew past the planet. But it is Mariner 9 that explores all of Mars and reveals a planet beyond speculation. The intricate spacecraft, operating at a distance of over 100 million miles, is commanded by a complex system of men and machines on Earth. 6 mission experiments yield results that can be woven into a total picture of a planet. As the spacecraft orbits Mars, the density of the atmosphere is measured by radio waves as they pass through the atmosphere on their way to Earth. The thin Martian clouds are scanned in the infrared to determine if they are carbon dioxide or water. An infrared instrument continually measures the changes in surface temperatures, ranging from minus 150 degrees Fahrenheit on the night side to as high as 70 degrees at noon on the equator. The height of mountains, the depth of canyons, and the gases in the Martian atmosphere are measured by invisible radiation in the ultraviolet and infrared wavelengths. Analysis of subtle changes in the orbit of Mariner reveals that Mars has an odd bulging shape, and this shape is a new clue to its internal structure. 2 television cameras photograph and map the surface of Mars. In nearly a year of operation, they transmit more than 7,000 photographs. Of these, over 1,500 are specifically taken to ensure that the entire Martian surface will be mapped. The photographs are carefully matched, precisely positioned on a globe, and skillfully fitted together. This shadow on the surface of Mars is cast by one of its two moons, Phobos, only about 13 miles long. The second moon, Deimos, is even smaller. They are the darkest objects ever photographed in space. Primitive chunks of rock battered by meteoroids, their origin is unknown. This is the face of Mars, photographed by earlier mariners. Here, a visitor might think he was on our moon, that this planet too was unchanging and dead. But transported to the other face of Mars revealed by Mariner 9, he would see fresh evidence of a living, changing planet. The old craters here have been long since covered by immense flows of lava. Thin white clouds form and drift across the dark blue sky. In the distance, he would see the long, gentle slope of a great volcano. Intense small dust storms scour canyon walls into sharp ribs of ancient rock. Near the poles, he would see a great series of ancient terraces, each layer composed of a mixture of dust and snow deposited by the wind. Each took thousands of years to form. Each is an episode in the history of the planet.
The exciting thing that we discovered, there were many of them, but one very exciting thing that we observed in the middle of the mission was that things were changing before our very eyes on the Martian surface. For example, in 13 days, an area about 7 miles across discontinuously appeared, just hadn't been there before, suddenly it was there. Now that kind of change had been observed, but from the Earth and on a larger scale, for 100 years. It was called seasonal changes, and the early observers imagined that there was plant life on Mars, and that in local spring and summer the plants grew. They darkened the landscape and heightened the coloration of the landscape. Well, we proposed before Mariner 9, my colleagues and I, that instead what was happening was that there were high winds that were uncovering the dark material, dark rocky stuff, by blowing off bright, fine particles. And the changes that we've seen on Mars happen during the course of the mission are consistent with this kind of idea. So it looks as if the seasonal changes of Mars are not due to biology, but due to weather. We calculate that the winds are maybe as much as 200 miles an hour in such a storm. And you see, you have to have very high winds to make that thin Martian atmosphere pick up fine particles from the surface. So while most of the time it may be nice and calm, there are storms which are much more violent than any we see on the Earth. Now, if you have very fast winds picking up all this fine-grained sand, that's a source of erosion and abrasion much more serious than any wind-blown erosion we know about on the Earth. It breaks things up, makes things collapse. It also picks up things and denudes landscape of overlying sand and dust. It's an exceptionally dynamic environment. In some respects like the Earth, in some respects quite different. It's its own planet. There are old parts of Mars which are cratered by hunks of rock falling down into Mars and making holes. In some of those craters, there are these strange black splotches. At least some of those splotches, on closer inspection by Mariner 9 cameras, turn out to be vast sand dune fields, another indication of wind-blown sand and dust on Mars.
There is a similar dune field in the Mojave Desert in Southern California. That is, the overall form of the two fields and the height and spacing of the larger dunes are alike. However, the complex pattern that we see here shows that the wind directions change frequently. On Mars, the wave pattern indicates a consistent wind direction.
Here is an astounding feature which no one expected on Mars. An enormous rift valley, almost 3,000 miles long, comparable to the largest such feature on the Earth, a sign of great geological activity.
In this model, the flat surface of a large Martian plateau is cut by the Great Rift. A smooth sloping ravine drops abruptly to the bottom of the canyon 4 miles below. The small peaks on the canyon floor were once part of the plateau surface. Today, this great fracture in the crust of Mars is 75 miles across. The original fault has been widened and shaped by various forms of erosion. Great landslides are triggered by quakes that shake the crustal rocks. Wind-blown dust strips the receding canyon walls. Some side canyons may have been deepened by running water. Melting of underground ice, followed by slumping of walls, further erodes the great fault.